So I'm going to try to put together just a little bit of a graphing review for you before I head for the weekend. You said that you were able to complete the first two graphs, so that would be the first two, I'm assuming, on page 1. Okay, if I am graphing, okay, both of these are called linear equations. And they are linear because when we look at the equation itself, we don't see any exponents. It is y to the first power equals 2x to the first power minus 9. So the exponents on the variables are both 1, which makes it a linear equation. Okay, and in that you see the word line. So you expect these two graphs to be straight lines. And you said you were able to graph for both of those. So hopefully you did that. If you're not sure where to start, you can always make a table of values. And you can choose different values to plug in for x. It's your choice. You might choose -1, 0, and 1. If I do that, it's actually going to go off the graph here a little bit. So I'm going to choose a 3, and I'm going to choose a 4, and just see what happens. If I plug 3 into that equation, it says y equals 2 times 3 minus 9. Well, 2 times 3 is 6. Minus 9, I get a -3. And if I put a 4 in there, I'd have y equals 2 times 4 minus 9. 2 times 4 is 8. Minus 9, I get -1. So if I plot those 2 points on my graph, okay, +3, -3 would be down here. 4, -1 would be here. Ideally, I would like to try and put those points in as well, but just in the interest of time, your line is going to look like that. I know from looking at the equation that it's going to be a straight line because that's a linear equation. So once I plot those 2 points, I can draw my line. Okay, and then I want you to be able to, I'd like you to be able to, hold on here, answer these questions from those graphs. What is the x-intercept? The x-intercept is the location where your graph crosses the x-axis. Where does it cross? The y-intercept is where does your graph cross the y-axis? That's your y-intercept. And then can you tell me the slope of the line? If you go back up here, this is in slope-intercept form. Okay, so we talked about how the coefficient in front of the x term, that's your slope. Okay, slope is rise over run. So for every, this would be 2 over 1. Since the coefficient in front of x is a 2, that's a 2 over 1. So for every 2 units it goes up, it goes 1 horizontally. So from up, you could have plotted a point, and then you can go up 2 and over 1. So your slope for that would be 2. This one is not in slope-intercept form. You'd have to put it in slope-intercept form before you can determine what the slope is. Okay, when you get to question 4, okay, this is no longer a linear graph. We call this a quadratic equation. Okay, this is a quadratic. Okay, quadratic because we see an exponent there of 2. Y equals x squared plus 3. We can still make a table of values to plot that. But what I expect a quadratic to look like is a U. I expect it to be a parabola that either opens up, that's called concave up, or I expect it to open down. That's called concave down. I know by looking at the coefficient in front of the squared term, it's positive, so I know that it's going to be, this particular graph is going to be a concave up. Now, where on the graph it is, I'm going to use my table of values to figure that out. So just plug values into your equation. Put that x value in, you take -1 and square it and add 3. -1 squared is 1. Plus 3, I get a value of 4. Then I'm going to plug 0 into that equation. 0 squared plus 3. Well, that's 3. And then I'm going to put a +1. Okay, 1 squared is 1 plus 3, I get 4. You can see that you get y values that repeat, and that will happen with your parabolas. So if I plot those points, and I draw my parabola. Okay, in class we talked about the axis of symmetry. The axis of symmetry cuts the parabola in half. So in this case, my axis of symmetry. It's a broken line that we draw. Go straight up and down. Because it's a vertical line, we label it x equals. All vertical lines are equations that say x equals. And what does x equal on that line? All the x's equal 0. The vertex is the very lowest point, or if it's a concave down, it'd be the very highest point. In this case, the vertex is 0, 3. So things that we want you to think about when you're looking at parabolas are where's the vertex, what's the axis of symmetry. Okay, it would still have, this has a y-intercept of 3. It does not have any x-intercepts, but sometimes parabolas will. These are quadratic equations. You're going to need to make a table of values, plot your points. You expect it to look like a U. In question 5, that's going to be a U-shaped graph, a parabola, but this one I expect to be concave down because the leading coefficient is -1. Because it's negative, it's going to turn the graph upside down. Okay, you keep going. Okay, you get to question 8 and 9. Those types of equations, these are called cubics. Okay, cubics because we have exponents here that are 3. That makes it a cubic. We expect cubics to look like this on the graph. They might start down and go up, or they might go this way. They might start up and go down. But that's what we expect the graph to look like because my exponent's a 3. Again, make a table of values. Okay, you can plot, pick out different x values that you want to put in. 0 is always an easy one to put in. Positive 1's easy, pretty easy to put in. Put in a -1. Put in a +2. See what happens to your graph. What does it look like? We talked in part 1, Algebra 2 part 1, we talked about the end behavior of the graph. Okay? Because it's a cubic, because it's odd, the ends of the graph are going to do different things. You look at the leading coefficient. Since the leading coefficient is a +1, that means that the graph is going to do this right here. It's going to start down, but it's going to finish up. So as you plot those points, you're going to know that it's going to look like that. Okay, when I look at 9, I'm going to make my table of values. I'm going to plug those values in, see what happens. But I expect this graph, because the leading coefficient's -2, I expect it to start up and go down. Now, where on the graph it is, I can determine when I plug in those points. Okay, so I would just say, make a table of values and see what happens. When you get done, see if you can answer those questions.